Chapter 1, Lesson 1. Here we have the set of real numbers. The set of real numbers includes rational numbers and irrational numbers. Rational numbers are numbers that can be written as the ratio of two integers, and they include terminating decimals and repeating decimals. So for example, you could have a terminating decimal such as 0.378, or you could have a repeating decimal such as 0.363636, and so on. In our examples here, it says write each as the ratio of two integers. So if we wanted to write -4 as a ratio of two integers, we would write this as -4/1. If we wanted to write 0.75 as a ratio of two integers, we could write that as 3/4. 0.6, we could write that as 6/10, 6/10, which simplifies to 3/5. 0.245, we could write as 245/1,000. 0.333 repeating would be 1/3, and the square root of 25 we could write as 5/1. Irrational numbers are numbers that cannot be written as the ratio of two integers, and we have three examples there. We have the square root of 2, which if we put that into our calculator, you could see would give us 1.414213562. Pi we could write as 3.14, not as a ratio of two integers, therefore that's irrational. And the square root of 26, also not a perfect square, so therefore cannot be written as a ratio of two integers. If we look below this, we have graph the following real numbers: -5/3, the square root of 2, and 2.6 on the number line below. -5/3 as a mixed fraction would be -1 and 2/3. So that would fall between -1 and -2. The square root of 2 is approximately 1.4, as we saw above, so we would be a little more than 1 there on our number line. And 2.6 would be between 2 and 3. Here we want to use greater than or less than to compare the following numbers. So we have 7 versus -3. We know that 7 is greater than 3. -2 and -5. -2 is greater than -5. The square root of 7. You know that the square root of 7 is less than the square root of 9, but larger than the square root of 4. So therefore this will be less than 3. The square root of 7 is approximately 2.6. And -5/3, which would be -1 and 2/3, versus -5/2, which would be -2 and a half. That tells me that -5/3 is greater. Here we have that opposites are additive inverses and reciprocals are multiplicative inverses. So 2 and -2 are opposites, and 2/3 and 3/2 are reciprocals. Here we want to look at a review of order of operations, and we use PEMDAS. First you do parentheses, second you do exponents or powers, third thing you would do multiplication and division, whichever comes first, looking left to right, and last you would want to do addition or subtraction, whichever operation comes first when you're looking at the problem you're trying to solve from left to right. So here we have some examples. Determine the value of each of these. So we have 2 plus 4 times 6 divided by 2. So if we go through PEMDAS, we don't have any parentheses, we don't have any exponents. We're going to look for multiplication and division, and whichever one of those operation comes first when we're looking at the example, we'll do that first. So here you have 2 plus 4 times 6 divided by 2. So you can see we have multiplication of 4 times 6. So we're going to do that first. That's going to give us 2 plus 24 divided by 2. Then we'll do the division of 24 divided by 2, which will give us 2 plus 12, which will give us a final answer of 14. Next, you have 12 divided by 2 times 3. So here we want to do the division of 12 divided by 2, which would be 6, times 3, which will give us 18. Next, we have 3 squared times 2 plus 4 divided by 2. So we'll start with 3 squared, which will be 9, times 2 divided by 4 divided by 2. So we'll need to multiply 9 times 2, which will give us 18. It looks like I have this wrong. This should be a plus 4. That's a plus, not a division sign. Then we'll add 18 plus 2 because we want to divide first. So we'll be dividing 4 divided by 2. And then 18 plus 2 will give us 20. And example 4, we have 3 squared times 2 plus 4 divided by 2. So we'll want to do the addition of 2 plus 4 for parentheses, which will be 6. We'll want to apply the exponent here, 3 squared, which will give us 9. So we'll have 9 times 6 divided by 2. 9 times 6 will be 54. You want to do that multiplication first. And 54 divided by 2, which will give us 27. At the bottom here, we have the properties of addition and multiplication. So the commutative property we have for addition, 2 plus 3 is this would be the same as or equal to 3 plus 2. So here you can change the order. Okay, so the order does not matter. A plus B would be equal to B plus A. Also applies for multiplication. 2 times 3 would be equivalent to 3 times 2. A times B is equal to B times A. So here the order does not matter. You can change the order and still have the same solution. The associative property, the grouping does not matter. So if you had the quantity 2 plus 3 plus 4, that's going to be equal to 2 plus the quantity 3 plus 4. Here you can see the order is actually staying the same. The grouping is changing. Same thing, quantity A plus B plus C would be equivalent to A plus the quantity B plus C. The same applies to multiplication. The quantity 2 times 3 times 4 is equal to the quantity, or equal to 2 times the quantity 3 times 4. The order of those numbers is not changing. The grouping is changing. The equation is still equivalent. Same thing for the quantity A times B times C would be equal to A times the quantity B times C. The identity property, A plus 0 is equal to A, and then A times 1 is equal to A. So you can see you're ending with the original term by adding 0 or multiplying by 1. Your inverse, you're adding the opposite, A plus negative A, which is equal to 0. For multiplication, you're multiplying by the reciprocal. A times 1 over A is equal to 1. And the distributive property we use a lot in algebra. A times the quantity B plus C would be equal to A times B plus A times C.